on with triangle congruence.
So we do proofs for this?
Yep, definitely doing proofs. That is the entire chapter. That is what this class is about, proving things. So yes, proofs. Today we are adding to our arsenal of things, angle, side, angle, and angle, angle, side. Notice not two sides. Now this means we have a side included between two angles. And this one is in the order I have an angle, I then have another angle, and then I have a side. So nothing's included. It's just in that order. So let's talk about being included once more. So here's a triangle, here's another triangle. We aren't going to prove anything about them. But if I label this, we have a triangle ABC here, and here's DEF. And just please look. I would say angle A is included between what two sides?
AB and AC.
Yeah, AB and what other side?
AC.
AC. So angle A is included.
How would you write that?
There's no symbol or anything like that. It's just understanding a definition. See, it's between those. Between what two sides is angle C included?
CB and CA.
CB and CA is included. You should be write this.
I am.
Being included, just the math way of saying between. Sandwiched, however you want to think of that. Sides can be included between angles. So between which angles is EF? Angle E and angle F. Between what two angles is FD? FD is between what two angles? Angle F and angle D. So what is angle, side, angle, and angle, angle, side? I mean, it's the same process as with side, angle, side, and side, side, side. If we can show that I have an angle, a side, and an angle in two triangles, then those triangles are congruent. And if I show angle, angle, and a side, then those triangles are congruent. So let's try using them. So here's our diagram.
Did you have to tell us L and O are right?
Yes. Or if it's marked in your diagram, that would be one of your givens. All right, so before we start a proof, we should think through how could I do this using my diagram. So I do have my angles. I have my right angles, and we know that all right angles are congruent. So I'll have an angle. And I'm given that L is congruent to P. So I'll have another angle. Now I have N is a midpoint of MO, which means what about MN and NO?
They're equal.
They are equal. So I have an angle, angle, and a side. So remember our options so far. Side, side, side. Side, angle, side. Angle, side, angle. And angle, angle, side. Don't be making up one that we haven't talked about. Okay, so statement 1 will be, let's go ahead, N is midpoint of segment MO, and that is given. And from that, I'm going to reason something. What do I reason from this?
That MN is congruent to ON.
Yep. And what reason could we give someone else? Why is segment M...
Because it's a
No, no, no.
Huh?
definition of a midpoint.
Definition of midpoint. That's what a midpoint does. It cuts something, a segment, into two equal halves. All right, so we have MN, and then we have our other two given. So angle M is congruent to, oh, well, we don't have that. Nope, 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 not yet. We have angle M and angle O are right. That's what we're told, given. What could I reason from that? Someone besides Daniel and Jacob. What could I reason off of this fact that M and O are right angles? Besides that they're 90.
Angle M and angle O are congruent.
Angle M and angle O are congruent. Okay, why?
Definite.
Given.
Nope, it's not given. I'm given that they're right. I'm not told that they're congruent.
All right angles.
They're both.
Yeah,
Yeah.
all right angles are congruent. Remember all those things I've been telling you that should be in the back, or some of you put it in the front of your notes. Those are reasons you can be giving in your proofs. That's why they're in your front or back of your notes, so they're handy. All right, so now I have said I have an angle, and then finally I have angle L is congruent to angle P. Why? That's a given. So now what could I say? Triangle LMN.
Is congruent to triangle PON, which is given.
That is not given. If I'm given that, then I have nothing to
Oh,
prove.
Angle,
sorry.
angle, side.
Angle, angle, side.
Break these.
Hey, why are you laughing? It's not funny.
Sorry, I keep on thinking the
What Justin said was funny.
All art stress is not humorous thing.
Mr. Kane, I just don't understand how you get these steps. Like, I understand maybe, I understand part of the statements, but I don't understand how
Listen, you are reasoning from this, all right? I'm given that. What do I know because I know this? I know that these are congruent. It's logic. It's something that you're going to have to get used to. What do I know because I know they're right angles? Well, if they're right angles, I know all right angles are congruent. I am trying to get one of these four in order to say that the triangles are congruent. So try to follow along with the deduction. It's logic. One step flows naturally from the previous one with the goal of getting one of these. Let's try another.
joking.
Can you do just AB then parallel DC?
Yes. In fact, that's how I'll write it in the thing. So we're going to prove triangle A, B, C is congruent to triangle C, D, A. All right, so if you're having trouble, pay close attention to how we use each of these givens in order to deduce something that gets us to one of these. Side, side, side. Side, angle, side. Angle, side, angle. Or angle, angle, side. I need to get one of these. What helps, Evan, is if you use this diagram initially to figure out which way you should go. Okay, so I see I have two right angles. Because I have right angles, I know they're congruent. So I have an angle. Okay, now notice how I have this side that's shared. Something equals itself, right? So I have that side. Now I have this line and this line are parallel, which makes AC a transversal. Do you see that?
Mm-hmm.
So it's kind of like I have this and this. Do you see some alternate interior angles?
Yes.
This one and this one are alternate interior. So that means they are
Equal.
equal. Angle, angle, side. Some of you didn't catch that. So let me get the parallel. These are parallel lines, right?
Yes, sir.
Because I'm given that. And this is a transversal. Remember?
Yeah.
Okay, what type are these?
Interior.
And what do I know about them?
They're equal.
Now, I don't have, if you like supplant that right here, kind of overlap it, those aren't the two I have. I have those two, right? This one and this one. Those are alternate interior, which means
They're equal.
they're equal. So angle, angle, side. So I'm going for this one right here. All right, so you could list all your givens right away, but I like to deduce from them, meaning form a conclusion. So angle B and angle D are right. And I know that because easy, given to me. I'm told that. Because they're right, what can I reason off of that, Kip?
They are 90 degrees.
That helps me prove something. Coleman.
They're congruent.
They're congruent. Angle B and angle D are congruent because...
The definition of
All right angles are equal.
All right. Midpoint has nothing to do with angles at all. We're talking about right angles.
Well, I was going off the last one where we had to.
Okay, but I have nothing about midpoint here, and I'm not even talking about a segment. Okay, you need to follow along with the one we're currently on. We're talking about that these are right angles. Because of that, they're congruent. Why?
All right angles.
All right angles are congruent. That's one of those things, again, I told you to put in your notes that is a statement or something that you can use as a reason. All right?
Line AB and line DC are parallel.
Yeah. AB is parallel to DC. Reason?
Given.
Now, because these are parallel, I can get a lot of different stuff, but the thing that's going to help me is this angle is congruent to that angle. That angle being angle DCA. So, angle DCA is congruent to angle BAC. Now that's not given. Why are those congruent?
Alternate interior.
Alternate interior angles are congruent. Now I have angle, I'm missing my,
Side.
okay, now how can I get that side?
AC is transversal.
It is a transversal, but that doesn't help me. Don't both
They
these
share
sides-
same-
Yeah, they share the same side. So segment AC is congruent to segment AC,
Reflexive.
reflexive property. Or if you forget that word, something equals itself. Okay, so do I have enough? Do I have one of these now?
Yes.
No.
Have I shown, have I proved my angle? Yes. Have I proved my other angle? Yes. Have I proved my side? Yes. So triangle ABC is congruent to triangle CDA by what reason?
Angle, angle.
Angle, angle, side. And I'm done.
So, whenever we see a problem, we need to figure out which one of these operations wins we need to do, and then
prove it.
Yeah, you want a goal in mind. You don't want to just start saying stuff.
Oh, okay.
Why do you have to put AC is congruent to AC?
So that's
Because
how
I
you're
have to
proving
state that side is equal. I need to explicitly state each angle that's congruent and each side that's congruent. Now, once I get the triangles congruent, and we're going to actually do this tomorrow, once I get triangles congruent, I can show every piece of the triangles congruent, which is going to be useful for proofs as well.
So you have to put it twice because both shapes share that one side.
Right.
Right.
But if they didn't, you don't have to put it. You wouldn't. Have
If
to
they
put it.
did, well, if they didn't share that side, then I wouldn't
Yeah,
be
it
able
would
to
be
prove
different.
anything.
Okay.
They would have to share that.
Okay. I understand.
Okay, so let's try another one. We're actually going to do lots and lots of these. Maybe 2 more after this. We'll see. Make sure all the corresponding pieces line up there. So we have some statements, reasons. All right. I'm going to use my diagram to tell me, boy, does that look like a right angle, but I cannot use that. I am not told that. It's not marked, nothing, so I can't assume that. All right, I am told that B is equal to Y, so I'll mark that. So I have an angle. Okay, so that's something I'm going to be able to use. I see that they share a side. So reflexive property I have right there. So I have a side. And then I'm told WZ bisects angle YW or VWY. So this bisects not this side, it bisects the angle.
So they're equal.
So these 2 angles are equal.
So angle, side, angle.
Careful.
Angle side.
Angle, side.
Sorry, I was. Well, we had an angle, side, angle.
Watch the triangle I have there carefully. I have an angle, I have an angle, and I have a side. Angle, side. It's not included. It's not between them, is it? Angle, side.
Wait,
It's not side. Look, side. Side, angle, side looks like this. Side, an included angle, and then a side. See the angles between them? Do I have that? Nope. Okay, so, and angle, side, angle, which hasn't come up yet, that would be, I have an angle, I have a side, and I have another angle. See, it's between them. Angle, side looks like I have up here. Angle, and then a side. See, nothing's in between anything. All right, hopefully you understood that. All right, so we have angle B is congruent to angle Y. Let's just knock that given out. We have our one angle. See an angle. Number 2, let's use this next given. WZ bisects angle BWY. That is also given. Now, off of this, I reason something because WZ bisects this angle. Do you see the angle it bisects? What does that mean about these 2 pieces?
It is
Angle BWZ equals what is congruent to angle CW.
Or YWZ.
Oh, shoot.
Make it equal.
Yeah, we do want to get our vertices in the right order. And what reason would we give?
Definition of a bisector.
Yeah, definition of bisector.
Well, we've already proved it.
Almost. We have two angles. We're missing one more piece.
WZ is congruent to WV.
WZ by reflexive property. Something equals itself. So I have angle, angle, side. Done. I have. You might even want to write it here. I have my angle, I have my angle, I have my side. Now be careful. The order of your proof might lead you astray. Use your diagram to figure out which one it is. All right. So triangle VWZ is congruent to triangle YWZ. You cannot memorize like this stuff. You can memorize your statements. You have to start to learn the logic, the thinking behind it, how you reason from your diagram and reason from your givens. So angle, angle, side. Boom. Happy. These are the easy proofs. Let's do one tricky proof. One tricky proof, and then we'll see what worksheets I might come up with.
While you're working through the worksheet, I said while you're working through the worksheet.
Hold on.
So this is one tricky.
One tricksy one.
I already see a vertical angle. We got an angle to both sides.
Can you leave it to us to figure out?
I already see a parallel, so those are equal.
That's gonna give me lots of stuff. That's very happy. Actually, this one's not gonna be tricksy.
Nah, I'm about to say that's real easy.
Yeah, that's what I was thinking.
You couldn't make that easier.
Mr. Man, I can't get 2 plus 2.
Well, he could, but he could just tell us. He could give us that they're equal and tell us to prove it.
Prove that A, B, and C, D are
Parallel. There we go.
yeah, given. Well, you put down a test to see if we actually are paying attention, that we know what we're talking about. You're going to give us the answer in the given. You're going to say prove it.
Yeah.
You have to just write down the given. That would. You would write that down, and everyone in the class would miss it.
Right.
That'd be terrible. Do we have this written down?
Yes.
gentlemen?
I didn't never show up results.
We might be able to get this a few different ways. We can get this probably by angle, angle, side. That'll be easy. We can also get it by angle, side, angle. We are going to use the angle, side, angle just because we haven't done that one yet. Let's reason from the diagram. Watch as I reason from the diagram. Because AB is parallel to CD, that makes this a what?
Transversal.
Which means this angle and this angle are equal because of what? Alternate interior angles. Now, do you see also this could be transversal?
Yes.
Which means this is congruent to this because alternate interior angles. So I have an angle, I have a side, and I have an angle. Angle, side, angle. Okay, so statement 1. Let's knock that out of the park. Segment AB is parallel to segment CD because given. In statement 2, we can actually, since we're using the same reason off of this parallel, I'll just combine it. So we have angle ABE is congruent to angle CDE, and also angle BAE is congruent to angle, which is it? DCE. And what reason did we give?
Interior.
Alternate interior angles are congruent. This wasn't that bad. And then we have our side is given, so segment AB is congruent to segment CD.
That's a given.
That's given. And now look, I have my angles and my side. But do you see why I don't want to say angle, angle, side? Because that just happens to be because of the order I put the statements in my proof. I need to reason from my diagram. It's angle, side, angle. All right, so triangle ABE is congruent to triangle CDE by angle side angle. And with that, we'll be done with notes.